Hello, welcome to the second video, my Sudoku series. This morning, I went on Logic Masters Germany again and found this puzzle Monsoon by heliopolix. There weren't that many puzzles this morning, and in the future I hope to do maybe some slightly easier puzzles than this one. But it already has 11 solves despite supposedly being 4-star difficulty, and it has 100% rating, so I figured it's probably a pretty good puzzle. I want to try it, and so I'm just going to record it. And let's go over the rules. So the only kind of non-Sudoku rule are these rain lines. So it says adjacent digits along a blue line may not be consecutive. Digits along a blue line have an equal sum n within each 3x3 box it passes through. If a line enters the same box multiple times, some each visits separately. Different lines may have different sums. Okay, so this kind of has two rules in one. So typical region sum line means, let's say I look at this line here, means that the sum of these two digits in box 4 are going to be the same as the sum of these 3 digits in box 2. But in addition to that, digits kind of, as you go along the line, they can't be consecutive. So, you couldn't have, say, 3, 4, 9, 5, 3, something like that. Because even though they both add up to 12, actually multiple times you've got digits that are consecutive, 3, 4, 4, 5. So you can't do that. So those are the only rules. And hopefully we'll be able to figure this out. So let's just do it. Let's restart the timer here. Okay. So I'm thinking about this like region sum lines. So I'm drawn to these lines where you have, one cell in one box and 3 in another. So that happens quite a bit. It happens here, 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 here. The reason I'm drawn to those is because, it's hard to have 3 digits summed the same as 1 digit. It's kind of the most restrictive thing we have here. And so if these were just region sum lines, I could pencil in, say, 6, 7, 8, and 9 into these boxes. But I think we can do a little better here, because I don't think any of these can be 6. Why can't they be 6? Well, if this were a 6, and so I should back up. Why, if these were normal region sum lines, could I say, well, this is immediately 6 or higher? Well, if I look at these 3 digits, they are, the lowest I could make them is a 1, a 2, and a 3, and that's going to sum to 6. So that's the lowest this could possibly be. Now in this particular case, I actually can't do this because this is for sure going to violate the adjacent digits on the line can't be consecutive rule, because one of these digits is going to be 2. It doesn't matter which one it is, even if you put it at the end of the line here. That 2 is going to be next to either a 1 or a 3. That's going to break the rule. So this can't be 6. I, in my head, first thought, well, it can't be 7 either, but actually it can. You could just have a 4 here and a 1, 2 on the outside. I don't know what my brain was thinking for a minute, thinking you couldn't do that. Now the other thing that is good here about these lines versus regular region sum lines is I actually know that there's a 1 here. Now normally I wouldn't, because suppose there's not a 1 here. Well, the lowest now I could make this is 2, 3, and 4. That would sum to 9. That would normally be okay, but now here, that's going to break our, I keep wanting to call it a whisper constraint, but it's not really a whisper at all, because in theory, they could be the same digit. Like on this line, right, this digit could be the same as this digit. So why doesn't this work? This doesn't work because one of these digits has to be 3, and no matter where you put the 3, it's going to have to be adjacent to either a 2 or a 4. And that's not going to work. So I have to have a 1 somewhere in each of these string of 3s that are attached to a single digit at the end of the line. So that's what I have so far. Looking at these other big lines, there's just too many possibilities to bother trying to pencil mark. And I'm interested in this kind of pattern of 4, 7, 8s, and 9s. It's not quite enough, I think, to do much more. And so now I'm inclined to try to do some sets. So set is this idea that I can look at two different regions that I know have to have the same digits and try to either say something about how those digits relate to each other, or the sums of those digits relate to each other. So I'll just give you an example. Uh, so, um, and I'm drawn in particular. So when I'm thinking about set, I'm thinking about how can I put some regions together that will kind of cancel each other out in meaningful ways. So let's look here. And I was drawn immediately to these diagonal region sum lines that go kind of one direction in one spot and another direction in another spot, because that's going to let me kind of cancel these out if I combine them. So so what I'm going to do is I'm going to draw some vertical lines here. So here I've got two regions, columns 4 and column 6. I'm going to highlight them in blue for a second. And these are each, a set of digits from 1 to 9. And I'm going to do the same thing again, going the other way in orange. And again, these are two regions with the digits 1 to 9. So I know that, at some level, these 18 digits are going to be the same as these 18 digits, right? Because there's just 2 1s, 2 2s, 2 3s, etc. And I also know then that they both have a sum of 90. Like both the orange cells and the blue cells have a sum of 90. And now I'm going to do is start canceling out by sums. Because these are region sum lines, I know that, well, these are just the same cell. So I'm going to cancel those out because now the orange region and the blue region are still the same set of 18 digits. I guess we've lost 4 in each region, so now there's 14 digits. And I now actually don't know what those digits are, right? Because I don't know what digits I took away. I don't know what those 14 digits are, but I know they're the same between these, right? And now I'm going to start canceling sums, and when I do that, I can no longer say that they're the same digits, but I can say that the sums are the same, right? So this sum is, well, it's not 90 anymore because I got rid of whatever those are, but whatever the orange sum is the same as the blue sum. If I take away regions along a region sum line, I don't know what the sum is, but I know that they're the same still, right? So orange and blue still have the same sum. If I take the same amount away from orange and blue, I still have the same sum. Same thing here. Same thing here. And I can actually do that along that line as well. And so what I'm left with is, good. So what I'm left with is these 4 orange cells, and that's what I was kind of hoping would happen, is that I have more, kind of a lot more orange cells, not a lot more, 2 more, but I have more orange cells than blue cells. And further, those orange cells have to be pretty high. So the lowest sum I could make these orange cells is I could make those both 7, and this could be a 1-2 pair. And that would give us 7 7 is 14, and 3 is 17. The smallest I can make those blues is an 8-9 pair. That's also 17. So here I am knowing that that is an 8-9 pair and that is a 1-2 pair. And that these are both 7. And so these are not 7. So, and therefore this is just by Sudoku now a 7. And because this is a 7 and this is a 7, I know that that is that 4-1-2 pair I showed you before. I'm going to get rid of this coloring because it's no longer useful. And now I'm thinking about these 8s and 9s. So in particular, I'm thinking, can these be the same or do they have to be different? Or do they have to be the same or do they have to be different? I'm not quite sure yet. Let's see, this is the same as this. Okay, now actually I'm sure. So if I think about these 8 9s, what I notice is that this 8 9 is the same as this one. So I'm going to color those purple. And I'm going to try to disambiguate my 8s and 9s. So if this is the purple 8 9, then this is the blue one. So these are different. So I don't know which is 8 and which is 9, but one's one and one's the other. So if that's the blue one, that's the purple one. And so that's the blue one, and that's the blue one, which means that these are actually different. And so between these 3 numbers, I have all of 7, 8, and 9. And further, I can see just by Sudoku that whatever the blue number is has to be on this little cell here, and whatever the pink one is has to be on this little cell here. I can do it vertically too. It's maybe a little less interesting. I didn't do this cell because if this were pink, because this is a region sum line, there's only one digit on it in each box, then this digit has to be the same as this digit. So if this were pink, this would be pink and that would break the puzzle. So pink's in one of those two spots, and blue's in one of these three. I guess I'll mark it for now. I'm hoping it will end up, at some point I'll either find out that it can't be here for some reason, or that it must be here. If it must be here, then I know that whatever this digit here is the other one on this line. So that will be cool. And now I'm thinking about, I've got these kind of 8, 9 pairs and 7s floating around the board. I'm trying to see, right, so this is interesting because, the kind of most this could be is 10 if this were a 6-4 pair, because 7, 8, 9 are gone. They can't be 6, 5, because those would be adjacent digits on these blue lines. And so the most this can be is 10, even though there's 3 digits, so there might be a 7. And now I'm kind of thinking about these 7s here. And actually I'm seeing that 7 is either on both of these lines or both of these lines. And I'm wondering which way they have to go, and thinking about this number 10 that I talked about. So suppose that 7 were on both these lines. I think this is not going to work, but I'm going to test it out just to make sure. So suppose that 7 were on this line and on this line. Because, I'm really just supposing it's on one of them. If it's on one, it has to be on the other as well, because 7, just by Sudoku. And if that's true, the lowest I can now make this set of 3 digits sum to is 10. I have a 7 in the middle, right? And a 1, 2 pair on the outsides of it. Same thing up here. And if I did that, what would have to go across from it? Well, that's that maximum sum I could make this before, which is 6, 4, right? This 4, 6 pair. Because, again, that's the most this could possibly be. And that's the least this could be now, assuming there's a 7 in it. And that's the most this could be. And so that's the only thing that'll work. If I make this more than 10, that'll break this sum, because this can't get any higher. But now if I have this, where do 4 and 6 go in box 5? I can't go anywhere, because the middle's full. And so these are different. Actually, that's going to tell me where the 7s are. So I'm just going to back all this out. So I know 7 can't be in those 2 lines. So it has to be in these 2 lines. And because of that, and then what I noticed going through that is these 4 digits and these 4 digits all have to be different, right? Because whatever digit I have in here, well, I know that blue and pink are different. And I know that these aren't 7 because I already have 7 in those boxes. So whatever I put here is not going to go in the middle row, so it can't go in the bottom row in box 4, right? Same thing over here. So these 4 digits are all kind of unique digits. So I've got these 4 digits, they're all unique. That means these 6 digits are all unique. That means these 8 digits are all unique. So these 8 digits represent the 8 digits, I think, everything except 7. I think that's right. I'm 99% sure that's right. I'm not going to use it yet until I can convince myself of that last 1%. But I'm pretty sure that these 8, because these 2, when I say see, it means that they kind of have to be different from by some rule or another. So these see this just by normal Sudoku. These see this by normal Sudoku. These see this by this weird, they can't be in the middle rule, unless it's blue, but then blue is over here. So this is different from those 3, and by the exact same logic, these are different from those and those by Sudoku, and these by the middle logic, right? So yeah, so now I'm 100% sure. These are 8 different digits from 1 to 9, everything except the 7, right? These are those 8 digits. And I'll just remember that. I'm not going to mark it, I think, because I don't know how that's going to be useful, but I suspect it might be useful in a bit. And now I'm drawn to this, this set of 7 is going along with a blue digit here, and 7 is going along with a purple digit here. So kind of what can go in there. Actually, no, I just had a different idea. So now I'm thinking, I was thinking about that, And I was thinking, well, then what can kind of the other digit be here? And I thought, well, it can't be a 1 because this is 7, 1. This is 8 and something. It could be a 1, I guess, but 8 and 1 is more than 7 and 1. So in fact, because this blue is definitely going to be more than 7, it can't be the same digit. It has to be less. So this can't be 1. And this can't be 1 by this 1, 2 pair being here. So I know there's a 1 here. I know there's a 1 here. Now I'm wondering if I can do the same thing with 2s, because I have this 1, 2 pair in the middle. I know that the 2s are either in, just like the 7s, I know that the 2s are either in both on this line or both on this line. And they can't both be on this line. Why not? Suppose that were true. Well, 7 and 2 is 9, which means these would both have to sum to 9. But one of them is a 9. I don't know whether it's blue or purple, but one of them's a 9. And 9 will have to be paired with something else. Even if it's a 1, that gets us to 10. That's going to break this. So this can't be a 2 here. So the 2 is going to have to be here. And now because I have 1 and 2, I know that it's not in the middle because that would be adjacent to whatever the other one was. So now I just have 1, 2 pairs in the corners here on those lines. And now I have this X-wing of 1s and 2s up here. That's wild. Which means my 1 on this line is in the middle, right? So because I have this 1, 2 pair here, there's not a 1 here. Same thing, 1, 2 pair here means that's not a 1. So I have this 1 now, and I know that one of these is a 2. I don't know which one yet, but I do know which one because I have this 1, 2 pair here. So now I've got a 2 on this little ring here. I haven't thought about these rings yet because they're kind of weird because I'm still mostly in the mode of thinking of these lines as region sum lines with like this little bonus restriction on them. But these don't even enter a different region. So the region sum component doesn't matter at all. So why are they here? It must be because of that. It must be because of the restriction on adjacency digits. And all 3 of these are adjacent to each other. And so basically none of the digits are going to be adjacent to the other. So kind of the lowest this could be is like a 2, 4, 6 triple, something like that. But of course it could be much higher. And in fact, I'm just looking here, where does pink go? In this box, it goes here. So 2 is here and pink is here. And that's going to mean blue is not here. Right? Blue and pink are not going to be able to be adjacent to each other. So blue is going to be in one of those. But that means pink is going to be in one of these. Where does pink go down here? Not sure yet. Let's see, blue, where does blue go? Oh, actually, so I know blue is in here because of this blue cell. This blue cell eliminates blue from the bottom row. So blue has to be in this triangle, which means pink can't be in this triangle. Oh, so pink has to be down here, which means that's not pink and that is. And so pink is now in one of these, and I have this X-wing of pinks. So that's not pink, right? Because, so what do I mean by X-wing? If I know that a particular digit is in, with X-wing it's typically 2, but in theory you could do this with any number of rows and columns. If I know that, if I take 2 columns here, in this example, columns 2 and 3, and I know that within those, and I can pair that kind of with 2 rows. Actually, it's the other way around. So before I had it like this. So if I look at these 2 rows, and I ask, where's the pink digit in these 2 rows? If I can restrict it to 2, because I'm only looking at 2 columns, if I can restrict the number, I'm only looking at 2 rows. If I can restrict where a particular digit can be to 2 columns in all of those rows, and if it were 3, I could restrict it to 3 columns, but for an X-wing it's just 2. Because there are 2 columns in both rows that digit appears in, I know that I'm either going to be in a situation where the pink digit is going to be in these 2 cells or these 2 cells. Either way, it's in one of these, and so it can't be up here. And so this is now my pink cell. So I'm almost done with pinks, and now I know that. Oh, is that right? No. We're done. Yeah, sorry. I've got these two and these two. So I've got pinks in all these places. So pink is, I mean, almost done. I need to disambiguate this pair and this pair. Blue, for some reason, is a little harder to pin down. But there we are. And now thinking about here, what can go here? Well, there has to be a 3 on here. Why does there have to be a 3? If there weren't, the lowest this could be is 1, 4, 5. That would get us to 10, and that's not going to work. And in fact, the other digit, if this were an 8, the other digit here would be a 4. And if this were a 9, the other digit would be a 5. So either 4 or 5 is here. Blue is out here. I don't know where 7 is, except that it's not there. I don't know where 6 is at all. So, okay, I'm not sure that's going to be much more useful. And now I'm thinking about these 1, 2 lines and how they pair off with this, and how these digits all interact. I'm kind of thinking about 5s and 6s, like where do the 5s and 6s go in this puzzle? I almost said you can't put them here, but you actually can. So you can't put a 6 here because of the 7, but if this were, say, 7, 5, I could put 9, 3 or 9, 4. Sorry, 9, 3 or 8, 4 in this to make it work. So that is not the key. What is the key? And I'm kind of just looking at each of these lines and thinking, can I do some restriction? Maybe it is these. So where does 3? No, that's not very helpful. So I'm thinking what goes with these 7s, and it's not 1 or 2. I mean, very clearly because of these 1s and 2s. So it's somewhere between 3 and 6, which maybe isn't that useful. I'm looking at like this one compares with this one, so one of these is a 1, but that's not so useful. And the same with the 2s, one of these is a 2. I'm trying to wonder, like, why can't it be in here? But it surely can be. Okay. So now I'm thinking about, okay, well, what goes in these cells? It can't be, so this has to be 5 or 6 actually. So that's good. So why does that have to be 5 or 6? Well, what's going to go here? It can't be 3 because that's going to be adjacent to a 2. It can't be 4 because of this 4. 5 or 6 maybe. Can't be 7. Can't be 8 or 9 because blue and pink are accounted for. So this is either 5 or 6. I can almost do the same thing here, but I can't quite because there's no 4. Like this was eliminating 4 in this row, but I don't have that same. I mean, the 4 in this triple is up too high. So this could be 4. And the fact that this is drawn this way makes me think it probably will be 4, but I don't know that yet. And so I'm going to label this cell, let's call it green. So where does green go in box 5? Well, it's got to be one of those 2 cells. And then where does it go in box 8? It's got to be in one of those 2 cells. And now I'm wondering, okay, if this were the other 5 or 6, where would it go? It would go in one of these 2, and it would go in here. I feel like something is there, but I can't quite see it. I can't quite see where that goes. And because, you know, this is a little bit meta, and maybe I shouldn't use this, but it's just trying to guide where I'm looking. I'm really looking for a reason this can't be 5 or 6. Because I think this is drawn that way to make this have to be a 4, or to like allow this to be a 4, I guess. I do the same thing here. This has to be a 3. There has to be a 3 on this, otherwise you get 1, 4, 5. Oh no, because there could be a 2 here. I don't have that 2. There could be a 2 on this. Like this could be a 1, 2 pair again with either 5 or 6. Shoot. Okay, well, so now this sum is either 7, 8, or 9. This sum is either 8 or 9. let's say if this were 8, what would go here? Can't be 1 7. It could be 2 6 or 3 5. It's not so exciting. If this were 9, then it's 3 6. Can't be 2 7 or 1 8 because 8 is either blue or purple. So that's actually, so it's either 3 6 if it's 9, or it's 3 5 or 2 6. There's no possibility of this being a 1. This can't be a 1. That's kind of interesting, actually. I mean, this has to be a 1? I don't know. I don't know. We'll find out, I guess. And can I do the same? So if this is 7, that could be 1 6. Okay, so this could still be a 1. Okay, that doesn't quite get us there. One of these is now I'm wondering, could this be 5 or 6? And I think the answer is no. Right? Yeah. So this cannot be 5 or 6. Because the lowest, if this were 5 or 6, sorry, by this I mean the other cell that's not blue. If that were 5 or 6, the lowest this could be is 13. But the highest this can be is 12. That's a 7 5. Because it can't be 7 6, they'd be adjacent. And 8 and 9 are taken. So the highest this could be is 12. If this were a 5 or, if there were 5 or 6 with the blue, the lowest it could be is 13. So there's no 5 or 6 here. There's 1 here. So there's 1 5 or 6 in this row. And there's 1 5 or 6 in this row. There's 1 3 or 4, so these 4 digits are 3 4 and 5 or 6. 3 4 5 and 6. In this row there's a 3 4, there's 1 3 4 and 1 from 5 6. Same thing down here. There's 1 from 3 4 and 1 from 5 6. And whichever one is here is going to be down here. Right, so I already said before, one of these is 5 or 6, just going through this. So whatever one is here is down here, and it's going to be not there. Right, and whichever one, yeah, so this is down there. So now I'm wondering, could it be this? I think it could be. Where's the other 5 6? Could it be down here? I think it could. I almost thought I had something, but so this 5 6 is in one of those two spots. There's a 5 6 in one of these spots. There's a 5 6 in one of these spots, but I don't know which one is the green, unfortunately. But I do know this is not 5 6. So that's 1 2 3 or 4, which means could this be 5? Now I'm wondering, does the 5 and 6, do they have to both be here? They certainly can't both be here because I have this green one here. So at least one of them is here. But do they both have to be there? And that's what I'm not sure about. So I'm trying to think, okay, suppose that there was something other. So suppose that there were a 3 4 here. So the 5 6 were something like this or this. Because that breaks something. And then right in here, 3 4 5 or 6. So if this were 3, that works. Oh wait, hold on a second. Does one of these have to be? I think one of these has to be 7 3. This can't be 4 just by Sudoku. If this is 7, if neither of these are 7 3. Yeah, if neither of these are 7 3, then 3 has to go in the middle in both boxes 4 and 6. So one of these has to be a 7 3 pair. Is that useful? Because if this is 7 3, this could still be 3 4. This could still be 7 5. And this could still be 8 4 or 9 3. So one of these is 7 3, and that 7 3 is going to get paired with either 8 2 or 9 1. This isn't 2. This isn't 1. Actually, should I just be doing Sudoku here? This is either 2 well, the thing is there's also a blue here. So one of these is blue and one of these is 1, 2, 3, or 4. So it's actually not that much information, but I can do the same thing here. Yeah. Can this be 5 or 6? 8, 5 is 13. Yeah, no, so this is the same thing. 1, 2, 3, or 4. So there has to be. Okay, now we are going to go back to the idea that there is a 5 or a 6 in. So these 8 digits are all different. So what do I have from here? I've got a 5 or a 6, a 1, 2, 3, 4, a 1, 2, 3, 4, a 2 or a 3. So one of these digits is going to be a 1, 2, 3, or 4, and one of these digits is going to be a 5 or 6. And that's going to pair with one of these and go along here, and the 5 or 6 from here is going to be one of those and go along here. But I feel like it's close. But can the 5 or 6? I can't go with 1. Because it could go with 1, because I have 6, 1 here, and 1, 2, 4 here. Oof. So, what do I do from here? Perhaps I chose too hard a puzzle. I'm just going through and I'm looking at all these lines and thinking, can I restrict things more than I've already restricted them? Like for example, I keep going back to the 7, 3 for some reason, thinking, could this be 7, 3? Well, I don't want to, suppose this were 7, 3. This would either be 8, 1 or 9, 2. Now we'll get rid of 1 and 2. Oh no, that breaks, because I said 1, 2, 3, or 4. Never mind. I thought there had to be a 1, 2 in here, but there does not necessarily have to be a 1, 2 in there. This could be 5, 3, and 1, 2, 5, say. Let's see. Now I'm wondering if this can be green or if this can be green. So let's say that this is green. So these are the same. Now this can't be green because that's the same as this. So it will look like that. And then this would be kind of the other 5 or 6. And so something like this. Doesn't help me. Okay, this can't be 6. I don't know why I drew that in there. Now I'm going around these corners thinking, okay, blue is going to be in some combination of, oh, actually, is this it? This might be it. So one of these has to be blue because blue can't be on this line because then this line will be too big. And it can't be any of those. So blue is kind of outside of this triangle as well. So if blue is outside this triangle, then from here, I only have possible the digits 2 to 7, which I wish I could just think like 2 to 7. But the reason that's interesting is I have 3 digits here that all have to be separated by at least 1. So there actually aren't that many, and these can't be 7. There actually aren't that many possibilities for what this could be, right? So it could be, like suppose there were no 2 here. I know now that's 3, 5, 7, right? I know that's 3, 5, 7 because that's the only way to get the numbers 3 to 7 here in a, so if there were no 2 here, then the 2 would go here with a 6. So does that work? If this is 1, 2 with a 6 in the middle, this is 3, 5, 7. This is 4, 8, 9. But that's not 4, so the 4 would be here. And this would be pink, and this would be blue. And then if this is 4, then this is 4. Yeah, I'm not seeing why that doesn't work. Obviously. Well, actually, I know that 4 is not here, so that's something. 4 is either, right, if these are the 8 digits that don't include 7, 4 is not here because if 4 is here, it has to go with a, because there has to be a 5 or 6 here as well. 4 can't pair with 5 because they'd be adjacent and consecutive. So this would be 4, 6, that'd be 10, but the most this could be is 9. So there's no 4 here. So 4 is either, it's actually either here or in one of these two. Does that get us somewhere? I don't see it yet. I don't see it yet. Don't see it yet. If this is 4, this is 8, and this is 7, 5. And then this is 7, 3. This is ridiculous. That's a 6. Becomes 1, 2. That becomes 9. This becomes 6, 3. 6, 3, 4, 8. Oh. Yeah. 6, 3, 4, 8. That breaks. Wow. I don't think this is the intended path, but I'm going to take it because I kind of saw it. So, oh my goodness, where do I start? Okay, so all I'm getting rid of is a 5 here. Suppose this were 7, 5, right? Then that, oh no, that's better. Suppose this is a 4, right? If this is a 4, then this is an 8, because the most this could be is 12, and the lowest this could be is an 8, because it's either, if this is 4, then this is blue, which is 8 or 9. So the lowest that could be is 8. So the lowest this could be is 12, the highest this could be is 12. They have to be 12. So I get this 4, 8 pair here. That 5 turns this into a 6, making this 9. If this is 9, this has to be a 6, 3 pair. And now the question is, I need to put 1 and 2 in this part of this box. In column 4, where do 1 and 2 go? One of them is obviously in the middle, but the other one's down here, so it can't be in the middle. And so that just doesn't work. Oh my goodness, that cannot be. There must be something easier, but I don't see it. And so now I know that this is 4 paired with either 8 or 9. So this is 7 paired with either 5 or 6, meaning these are 5 and 6. So that is not a 5. That's not 5 or 6. That's a 4. That's my 7, 3. This can't be 3. This is either 8 with 2 or 9 with 1. So I'll just fill that in here. And so this can't be 2, because either 1 or 2 is here, the other one's here. This is a 3, 4. In fact, this has to be 3, so that's 4. Okay, I feel like we just had a major breakthrough. So maybe that wasn't, if that was intended, there just has to have been an easier way. I don't understand what the idea would have been. Okay, so this is either 1 or 2. And this is totaling 7. So if it's 1, that's going to pair with 6. 2 would pair with 5. And the other 5 or 6 is here. I'm going to get rid of these greens. I don't think they're doing anything right now. 1, 2, 5. So this is 4. Right, we already said this is 4 with either 8 or 9. And that goes with 5 or 6. Okay, now we're stuck again. So now what do we do? Now I'm looking at these and trying to think, can I sort out, oh, actually I can do a little better. So 1 and 2 have to be here, because I've got kind of an X-wing on 1s and 2s in these cells. So 1 and 2 have to be here. Same thing with 5s and 6s. Oh wait, no, not with 5s. Sorry, this has to be with 3s and 4s. 3, 3, 3, 4, 4. Those aren't really X-wings, they're just Sudoku. That's not 4. And then the other thing that goes in each of these is the other 5, like kind of missing 5 or 6. Okay. Now I've got this X-wing on blues, sort of, where blue has to be in columns 7 and 8 in these boxes. So blue is in one of these cells. What could this be? This could be anywhere from 3 to 6. That's not helpful. I'm looking at before. 3, 5, 6. That's almost helpful. Okay. And I'm looking at, so this 7, I keep going back to this triangle and wondering what is in it. What is in this triangle? And same thing up here, right? 7, if 7's not here, then 7's in here, and that means pink is 9. And same thing down here. If 7 is, oh no, not the same thing, because blue's not in here. Blue's in one of those. The asymmetry between this and this is really messing with my head. I feel like it should be symmetric, but it just isn't. It just isn't, because of the way the pinks are ending up. I mean, really, what it is that the triangle is on the inside of the square here, and it's on the outside of the square here. But because they're both on the bottom left, that's tricking me into thinking it's symmetric. So I'm going to look at this. So, okay, 7 is either down here in this triangle, or it's not. What happens if it is? If it is, then 7s are here and here, and here and here. Does that help me? What is that getting me? Maybe nothing. And here, okay. So if 7 is not in the triangle, then 7 is getting paired with blue, and blue is 9. So that's if 7 is in. What if 7's not in the triangle? If 7's not in the triangle, then 7 is down here. Wait, is that right? Did I make that up? Yeah, because again, I've got this X-wing of 7 sorts in boxes 7 and 8. So 7 has to be in one of those two. Wait, does that actually get us what I think it gets us? No, because 7 could be up here. I feel like I'm close to something. Let's try it the other way. So suppose 7 is here. Then, well, first, suppose 7 is down here. If 7 is down here, then pink is 9. If 7 is up here, then 7 is down here. It could be here or in the box. Maybe there's a different way to think. So, okay, maybe there's another way to think about this. If 7 is in this box, what did we say was 9? If 7's in the box, then 7 is here and here and here, and therefore, oh, and here. Therefore, blue is 9. Yes, okay, blue is 9. Okay. Suppose 7 is in the box. Suppose 7 is in here. If 7's in here, then 7's not in here, so it's one of these two cells. Sorry, it's not in any of those, so it's in this triangle. 7 is in the triangle with blue, so blue can't be 8 because it'd be adjacent to a 7. So blue is 9, if 7's in here. If 7's not in here, this triangle is 2, 4, 6, because that's the only way to get 3 cells that are 3 digits that are not adjacent to each other at all. They have to kind of go up by 2 at least, between the numbers 2 and 6, because now there's no 7 in the triangle. And if this is 2, 4, 6, the lowest this can be is 1, 3, 5, meaning blue is 9. So either way, blue is 9. That is, I mean, it is a 4-star puzzle, I suppose. So blue is 9. And 9 is, yeah, I'm going to start erasing some coloring. Right, and if blue is 9, then pink is 8. Pink is 8, wow. And if pink is 8, okay, and if pink is 8, that means this is 8, 4, so that's 7, 5, which means this is 6, which means this is 6. A 3, 6 pair, that's 5, that's 6, that's 6. Don't stop now, keep going. Did we, okay, and that means this 5 here 6, 6. This is 6. That's not 5. This is not 6. And since that means this is 2, 5. That's 1, 2. Okay, now I feel like we're getting somewhere, but not there. Is it just Sudoku? So what's not Sudoku? I've got this kind of potential 2, 3 conflict. I have this region sum still. Let's see, actually what goes here? 4 and 5 are in here. So this can't be 4 or 5 pairs. So the 9 is in here, and it's in here with 5. So that's 4. This can't be 5. 9, 5. Okay, now I can just get rid of this blue coloring. In fact, I can just get rid of all the coloring. Wow, this is a busy board. I apologize for how busy this board is. There are too many markings. I'm having trouble seeing what should be here. If this is 8, that means these are 3 and 4. If this is 9. So now this could still be 1, 2, 6 if this were 3, 5, 7. So it can't be 2, 3, 4 because of that adjacency problem. It could be 1, 3, 5 or 1, 2, 6. I know 4 is down here on this triangle. So 3 and 5 are not. So 2 has to be on this triangle, which means this is 1, 3, 5. And the 9 is up here with either 6 or 7. We're almost done, but not quite there. Not quite there yet. This is a 6 because it can't be 1, 2, 3 or 4 or 5 or 7 or 9 because that'd be just into the 8. So that's 8 and 6, which means this is 5, 7, 9. These can't be 7. So that's my 7. My 7 now is in this column in box 9. What's this cell? 1, 2, that's a 3. So that's not a 3. At this point, it's just Sudoku. Hopefully, we'll be done fairly quick, but there might still be a trick up Heliopolix's sleeve. Okay, what goes? So this could be 9, 7. It doesn't have to be, right? It could be 9, 6. This 6 gets rid of these 6s. It could be 9, 5, 3. Be 9, 7, 5. I mean, there are so many possibilities what this could be. 1, 2. Oh, actually, no, but 3 is on the triangle because of this. So this 9 is 3. I mean, 9 and 3 on the triangle. So, well, I already know 1, 2, 4. No, that's not useful. That's not so useful, is it? So 9 and 3 are on here with either 5, 6, or 7. 8 is down here with the other two of 5, 6, or 7. And this 8, 4 is actually going to tell us which way the 7, 5s go. So if this is 8, this can't be 7. So it's either 8, 5 or 4, 7. But I don't know if that helps me. This is a 1, 2 pair, so that can't be 1. So therefore this is a 1. So why is this a 1? I've got essentially a x-wing of 1, so the 1 in box 1 is in columns 2 or 3. The 1 in box 7 is in columns 2 or 3. So another way to think about that is where does the 1 go in column 1? It's not here, it's not here, because of this one, so it has to be there. So this is a 2, 5 pair. And now I have this 1, 2, 5 triple. This 1, 2, 5 triple. This can't be, okay, no, that's simpler. 8, 4. This 4 tells me that that's 8. That can't be 7 now. 5, 7. Where does that keep going? 5. So that's now 3. Then I have another 1, 2, 5 triple. So that's not 2. So this is 1, 2, 5. What's left? 3, 4, 6, 7. Now 4 is gone. 3, 6, 7, 8, 9. Where does 8 go in Column 2 can't be here, here, gotta be here. So now I've got this 9, 9, 9, but that 9 tells me where the last 9 is, not the last 9. What more 9s do I need? That's not a 9. So I'm almost done with 9s, except I've got this pair to disambiguate. Can I do something? So this is not 4, so that's 4, because there has to be 4 in the triangle. It's the only place it could go. Or, just simple Sudoku is the only place it could go in the box. My 4 is done, not quite. 4, there we go. That tells me where the 3 and the 4 go. That tells me where the 4 goes here. I've got a 9-5 pair, so this is a 3-6 pair. And I know this 3 tells me where that goes. 6, 3, 6, 8, 6. Tells me the 8 goes here. 7. Wait, is that right? I feel like I messed something up. Hold on. So the reason, sorry, I think I made an error somewhere. The reason I think it messed me up is, so I just looked ahead a little bit. So if this, this has to be 9, 3, 6, 9, 5, 1, 5, 7, 2, 1, 2, 1, 2. Maybe that does work actually. Does that work? Sorry, maybe I'm just fine. 3, 6, 1, 2, 9, 5, 9. No, it doesn't work. Okay, but not for the reason I thought. Sorry, that was just, so now I'm going to try to see if I can find the error. So everything I've been doing is very simple. So I'm going to try to back up and see where I made a mistake. That's all just putting in digits. All very straightforward. Oh my goodness. I apologize. This is... Where did I go wrong? This all seems pretty logical. Oh no. Okay, sorry. So this is where I made the mistake, I think. Maybe I made another mistake before this, but I was applying this constraint, but not the region sum constraint, just the, I was just applying the consecutive constraint along this whole, along all 3 of these cells, but that's not true. So when I said this was a 4, which is correct, I said this is now 5, 9, and this couldn't be 5, so it had to be 9, 5, but that is not correct. Because these could be adjacent, that'd be fine, there's no problem with that. So I'm not going to put it the other way because that would be relying on the error I made. I don't think that is fair. So I'm going to see if I can figure out what I'm actually supposed to do here. So apologies for leading everyone astray, mostly myself, I think, here. So, okay, so what I'm supposed to be doing here, I've got this 8, now this is 3, 4. The 4 tells me still where this 3, 4 goes. So I think a lot of the logic is going to be the same, but I will end up being able to do, hopefully, the right thing and not the wrong thing. So what do I do next? This here? No. Yeah. How do you get to 9 here? How did I do that? No, I know that, so what's this? If these 4s mean there has to be a 4 on this, which means there can't be a 3 or 5. So there has to be a 2 as well, and then either 6 or 7. And so this is 1, 3, 5. Somewhere I'm going to get, so this has to be a 3. Now I've got this 1, 2, 5 pair. Was that what I did? No. Well, let's just keep going and we'll get there eventually. 1, 2, 3, so 5, 6, 7 in these cells. 7 can't go here because this next would be adjacent to an 8. Can't go here, so that's 7. And then I've got 5 or 6 in those cells. This is 3, 5, or 6. It can't be 3, so that's 5 or 6. And so now I've got a 9, 5, 6 triple here. That tells me this 3, 6. I'm remembering these 1, 2, 5, but maybe those won't show up now. Maybe that's what broke it before. Well, hold on. I got a 1, 2 pair here, so that's not 1. I've got this 1 X-wing here, so these aren't 1s, which means the 1 is here. That's a 5, so this is still 3. And so I do still get the 1, 2, 5 triples. So what's left? That's not 4, that's my 4. 1, 2, 5. So that's not 2. My 2's up here. The other 6, 7 is going to go here. That's not 7. Those aren't 6. Just by a Sudoku. 6, 7, 3, 6, 7, 8, 9. Where does 8 go? So yeah, all the logic's still the same as before. I'm just going to end up, I think, with a different 5, 9 setting here. So where does 8 go? In box 2, it must be there. Where does 9 go? Oh no, but so now it's going to be different because I don't have this 9 here. Okay. So there is still Sudoku. There's still something to do. What is this going to be? This is going to be a 5, 6 pair. I don't know which way yet, but this is now an 8, 5, 6 triple. So yeah, there it is. So now I flip this the correct way now. And in fact, I could have done it a little bit earlier by noticing that the 9s here formed an X-wing, giving me the 9 there. So this is 9 or 7. We said that 3 has to go in here with either 5, 6, or 7. I don't know which. So yeah, I'm literally just thinking through like I'm just doing Sudoku now. I'm looking at all the triples, seeing if that tells me. So this is like 3, 6, 7, 9. So this is 6 or 9. 3, 7, 9. That's not 5. Is there something with this 5, 6? So so whatever this 5, 6 is going to have to go here. It's going to have to go here. So it's going to have to go here. It's not quite enough. Is there something with the 1s and 2s? So 1, 2, 1. Oh, duh. Sorry, there's a 2 here. 1, 2. That's going to disambiguate a lot of 1s and 2s. Oh, I thought that was. Oh, it does. Yeah, 5, 1, 1, 2, 1, 2, 2, 5, 2. And this 2 means this can't be a 3 now, so we have a 6, 3. That's now 9, 7, 6. That's now 9. That's 9. What's left? 3, 7. And yeah, I just need to look for the Sudoku now. That has to be a 3, 7, 3, 7. These can't be 5. This can't be 5, but that doesn't quite help me. That is frustrating. What goes here? So There we go. 6 means that's 5, 6, 5, 6, 5, 8, 1. What's left here? 7 and 8. So there's no. So that's 9. This is sorry. This is 3, 6, and that's going to be 3 and 6 and 7 and 8. And is that correct? Wow. Apologies for the long video, an hour. The video will be even longer. But that was Monsoon by heliopolix. It was very stressful, but it had some really cool logic in it. And thanks for posting it. I enjoyed solving it. All right. Good luck. I hope you tried it on your own and had a good time yourself.